Thank you. Good afternoon, everybody. My name is Biren Gandhi, as Ted introduced. As part of Cisco's corporate strategic innovation group, we focus on two main work streams. One is strategy, other one is innovation. So as part of strategy, we work closely hand in hand with corp dev teams on mergers, acquisitions, investments, identifying interesting startups, scouting them, all the way to performing due diligences and eventual closure. And on the innovation front, we try to leverage various vehicles, innovation centers that Cisco has in a number of countries outside of US, or even university research, consortium initiatives, bunch of other initiatives to push futuristic, highly speculative, interesting technologies ahead, and drones obviously being one of them. In addition to drones, we are trying to work with other innovative technologies which are gaining a lot of momentum these days, like Bitcoin, blockchain, deep learning, etc. So it's going to be a very interesting time. Most of the time when I present at Cisco and drones, like why? People have this big question mark looming in their minds, like Cisco and drones, it doesn't look like it's matching up. But without any delay, my answer has always been, why not? As we have witnessed in the last couple of days, we are sitting at the forefront of an amazing wave of drone adoption, acceptance, and acceleration. And there are a lot of elements that Cisco is trying to push as part of its Internet of Everything strategy that are coinciding with the world of drones. The ecosystem that drones facilitate to build exactly aligns with the vision of Cisco as part of its Internet of Everything. How? As most of you might be familiar with, the Internet of Everything is intelligent connection of four elements: people, process, data, and things. And these four elements interact to create new value, new business opportunities. How exactly? So for example, in the people side of the thing, it's connecting people in order to be more relevant, more valuable ways that unleashes tremendous values. One example is collaboration technology. For example, previously, for all the meetings, you had to be in person, face to face, fly around the world. And now, with the power of web, internet, and collaboration tools, you are able to have virtual meetings irrespective of where you're located. That's just one example. Social media, we have all observed the power of it, and I've witnessed firsthand. I'm humbled to be part of early days of Facebook, so I've witnessed the power of it firsthand, that how fast message can go through and how fast the adoption can take place in connecting people across the globe. That's the people angle. The process side, it's delivering right processes, right amount of information to the right entities at the right time. It's a big challenge. We deal with a lot of noises in terms of data deluge, but how do you find the right kind of information? And when I say right entities, previously those entities used to be human beings, but with Internet of Everything, with drones and with robotics and all that, those entities, the lines are getting blurred. Those entities are no longer only human beings, but those entities could be machines, could be vehicles, buildings, anything what you can think of. So having an intelligent interaction, smooth interaction across these entities, it's equally important. The data, we are all aware of like a data, information, knowledge, wisdom, kind of a cliche, but that's much more important with a growing number of sensors, growing number of data points that we are trying to capture today. Getting the right value out of that data is more important, filtering out all the noises. And the way we envision is not just the cloud. Typically in the consumer side of the things, okay, you connect your device, equipment, wearable, gadgets, whatever it is, to the cloud, and you have this nice mobile app which can take care of everything. Unfortunately, that vision falls short in the industrial domain, where things are not yet connected enough, or sometimes even the connectivity itself is very limited, very restricted in the remote areas where there is no wireless connectivity, no Wi-Fi, no cell towers, nothing exists. So in those cases, there is a deliberate need to have low-level processing closer to the edge. Cisco calls it a fog computing, just like fog is closer to the ground than cloud. So fog computing is like moving closer to the data capture points in the field. So drones is a classic example of those. So how do you effectively process the data? And things, these are like physical things like sensors and n number of things that are getting connected not only to one another, but to the internet, intranet, and variety of human beings to unleash like smart decision making. And when you look at these pictures, this is a classic Cisco story of Internet of Everything. But when you try to superimpose drones, the world of drones is exactly trying to achieve the same principles. It's trying to put in action the exact same things that Internet of Everything is trying to achieve. For example, collaboration or access to people or human capital. Maybe it's in the time of normal times like public safety, security manner, or maybe disaster catastrophe areas. But connecting people through drones is also equally important. Process side, a lot of legacy, and as we saw in just the previous presentation, a lot of legacy, manual, labor-intensive, costly processes are being replaced by automated, smooth, low-cost, low-risk operations by drones. It's getting automated. The barriers are still high for wider adoption, but still, we are getting there. In terms of data, as I was saying, like layers of data process on the drone itself while the machine is flying. Maybe some lower level compute, you can capture the data and make some quick decisions on where to fly or what data to store and what data to discard, because you have limited space, limited processing capability on the flying machine. So you want to optimize on both the battery power, payload, the storage capacity and everything. So how do you optimally process data on the drone itself? Or the next level up is the ground station, or next level up might be somewhere else in between the network, all the way going to the cloud. So you can have 4 distinct layers like drones themselves, ground station, intermittent network points, or cloud, 4 distinct layers in the larger fog computing paradigm. Anywhere the processing should or could take place in a seamless fashion. And the things, we have heard like numerous sensors like LiDARs and ultrasonic, infrared, you name it, those sensors generate massive amount of data. So how do you effectively capture those sensors into this amazing world of drones to bring value? But how does it all relate to our future? I mean, yes, we know it's a lot of interesting applications, but how does it really relate to our future? When we think about drones and sensors, let's expand our view. Let's go to a macro level. Every individual sitting in this room and outside, we all are going to be walking sensors tomorrow or some point in the future. From breathable sensor fabrics or digestible pills, smart fabrics, sensors, wearables, anything, you name it. People are going to carry at least 10 sensors on their body in the near future. And the same thing, the tables, chairs, TV, everything is going to be connected. So sensors are going to be everywhere. And how we connect to them is going to change fundamentally in a radical manner. The process is also, they are going to unleash new business models because of this increased connectivity, increased visibility across this variety of sensors, variety of data collection points, and variety of processing models, fog, cloud, hybrid, in between, or think of something else. Who knows what comes out tomorrow? The data. We have heard numerous stories about data, like how much we generate and what's like noise and all. It's an interesting fact I keep on reusing. It's intriguing. So by end of 2015, we will be generating new information every 8 minutes that we have generated in the entire history of humanity until 2008. And that rate is accelerating as we move forward. So in 2016, if we are here, maybe this stat will change and says, oh, we will be generating in 1 minute whatever data we generated until 2011. Who knows? Or maybe more. In terms of connected things, it's estimated that by 2015, around 10 billion things roughly will be connected in the world. But the large number is in the next 8 to 10 years, 50 billion things, variety of things, and human beings are going to be connected. So the world is becoming more and more connected, as we know. But so everything, whatever we can imagine, the cars or stoplights, buildings, lighting, you name it, and the cars, automotives, autonomous cars, drones, helicopters, flying objects, non-flying objects, whatever you can imagine will be connected, and whatever you cannot imagine will also be connected. And these are the real examples. Cows themselves or any other livestock can notify their owners or farmers or stakeholders about their own health, about their digestion, nutrition, and many other factors with ingestible sensors and other pills. So the world is becoming more and more connected, but we just have scratched the surface of it. It's just the tip of the iceberg because 99.4% of the things are not yet connected, even by those estimates. 1.5 trillion things remain unconnected despite all these advancements across the humanity. But the enabling technology for connecting these various things, Internet of Everything, what are those enabling technologies? Those technologies are accelerating at a much higher pace that we can imagine. In the past, we have heard about Moore's law and computation power doubling and all that, but that law itself is kind of getting redefined in the future. The pace is amazing. The necessary elements of tomorrow's technology, the wireless connectivity, the compute and storage size, the processing power, everything is changing, increasing rapidly. Just quick example, wireless connectivity, both Wi-Fi or it could be cellular, they're expected to grow 16 times at least than what it is today. Advancing technologies like LoRa or long-range communication schemes. I mean, today we are relying for drone communications, we are largely relying on 4G LTE as the top of the line because that's the best you can get today. But it doesn't have to be that way 10 years out. New technologies will have to emerge in order to cater to the needs of the high amount of data that we are going to generate. The computing power is expected to grow 32 times at least again over a period of the next 10 years. And it's not just about the speed. The size required for this kind of computing power and computing capability, power required for this kind of computing, storage needs, that is going to go down 100-fold. So with very small amount of computing capability, the footprint, both a real estate footprint as well as the power footprint, you can achieve colossal amount of data processing results over the next 10 years. And that is where these technology foundations are moving. One more example, just by 2025, the power of the smartest smartphone here, iPhone 6s or maybe Samsung or LG, Nexus, you name it. The smartest smartphone's entire power can be embedded inside a simple frame of the glasses. We have seen Google Glass as one starting point, but more is yet to come. That is assuming the glasses will still be around and not replaced by those smart contact lenses for personal comfort or whatever reasons, but these are the kind of computing enhancements we are talking about. If we take a walk back in the history a little bit, the first general purpose computer which was announced in 1946, ENIAC, it was occupying 1,800 square feet space, weighing 30 tons, and was developed at a cost of $5.5 million US in those days, and was providing phenomenal capacity of 5,000 operations per second. And fast forward to today, this little greeting card, electronic greeting card, which kind of plays jingles and some sounds and some musical notes, available less than $5 at most of the department stores. It is 800 times faster than that 1946 ENIAC. Not only that, it's 1.1 million times less expensive and 1.7 million times smaller in footprint than the biggest general purpose computing machine a few decades ago. And if you have to map these power of a single greeting card into ENIAC-like architecture, it would cost $4.4 billion instead of $5.5 million, which was the original price point for developing ENIAC. So think about it, how much power we are generating and we are accelerating. The enabling technology, the technology foundation of this entire IoE is changing exponentially. Things which seem impossible today are definitely going to shout, I am possible. Things that are unimaginable today, they are definitely going to be the new norm of tomorrow. And why? Because there are going to be 8 billion, at least, again, all these estimates are minimum, the lower levels, lower thresholds. At least there are going to be 8 billion people by 2025, and surprisingly, by 2050, 70% of that population, the world population, is going to be living in urban areas. So whatever the infrastructure we are talking about, the intelligent infrastructure, the cities and the cars and everything, it's no longer going to be a choice. We have to adopt that infrastructure in order to survive, in order to still keep planet Earth as a livable entity, as a living, breathing home for all of us. It's not a choice that we have to adopt this intelligent infrastructure. A simple example, a simple light pole, the street lighting, can no longer afford to offer only the lighting service. It needs to grow and expand itself to provide much more better services like sensing other things, communication provision, safety, security, parking assistance, for example, or entertainment or internet connectivity for whoever is not there. So, bunch of applications need to be enabled and unleashed. You cannot rely on one thing providing one service anymore because sheer footprint of the planet Earth is shrinking, relatively speaking, compared to the population size. So, we need to pack more power into a single equipment, single device, single sensor, single actuator in order to leverage more out of it. We saw cars is obvious these days. So, connected cars may or may not be autonomous, but at least the connected cars, there are going to be at least 500 million connected cars by 2025. And majority of them could be autonomous if the regulatory approvals and technology advancements they proceed further as they have been in the recent history. But everything connected by IP connectivity, addressable, it brings out more like security risks and hacking risks and all. So we need to address those concerns and risks. But still, despite those risks and concerns, the opportunities are enormous. So these cars can obviously talk to one another, they could talk to pedestrians, they talk to buildings, they talk to trees, they talk to roadside infrastructure, whatever, in order to make driving safer, greener, more efficient, pedestrian experience also much better, risk-free. And the drone infrastructure can provide an air cover to this on-the-road infrastructure as well. It's an extension in the third dimension, and many more further applications can be unleashed using drones in this. And obviously, there might be some challenges as well along the way. It's not going to be free, but as we heard over last couple of days, insurance-related, legal challenges, regulatory challenges, we need to collectively address those. We cannot just offer a blind side and say, hey, the problems are going to go away, or it's a Boolean decision making, it's here or there, don't fly below 500 feet. That's not a solution. We need to do better than that. We can do better than that if we work collectively on addressing those challenges. Cisco specifically is exploring many opportunities in this land of drones, connecting with the Internet of Everything. So for example, on the people front, we are definitely looking forward to expanding our collaboration applications and public safety security applications, working with government agencies, law enforcement agencies, disaster nonprofit organizations to connect people using drone as a foundation technology. In terms of process also, the entire workflow needs to be maintained. It's not like the ecosystem today is quite fragmented, like certain companies are specializing in making the airframes or batteries and navigation systems. Certain companies are data experts. Certain companies are domain experts. It all needs to be connected in an Uber-like fashion tomorrow so that somebody on a whim can say, hey, I want to inspect my farm, which is 1,000 miles away in the middle of nowhere. And with few clicks, that person should be able to schedule that entire operation using drones, not just like fly it out, schedule the right authorized certified operators, fly it out, collect the data, scrub the data, analyze the data through some agrotech sitting somewhere in the other side of the world, get the meaningful results out within reasonable amount of time, less than 24 hours. So that's the kind of end-to-end workflow and ecosystem we are thinking about. And there can be like sophisticated app store-like model where third-party developers can also chime in, and their applications are just easy to use. Somebody might be specialized in agriculture domain, somebody might be specializing in mining domain, somebody might be specializing in this electric grid inspection domain. Everybody should have a place in this bigger ecosystem for everyone to win and cherish the results of this beautiful ecosystem. On the data front, analytics and fog computing, as we were saying, they are going to be key drivers for future. Not everything just shoving into the cloud, it's not going to be the solution. Or doing everything on the drone also, it's not going to be the solution, because it's economies of scale going to prevent us. There are laws of physics that limit certain things. So it has to be much more flexible. Do the data processing wherever it makes sense, instead of just blindly doing it in one place versus the other. If it makes sense to do it at the drone level, just do it there. If it makes sense to do it at the ground station, do it there. If it makes sense somewhere else in the network, do it there. Depending on the real-time characteristics of your data, expectations of your data, you could decide to do the processing of data anywhere in the network, starting from drones all the way to the cloud. And on the thing side, the connectivity, Cisco is obviously a trusted name in the connectivity, wired and wireless connectivity. So maybe it's a connectivity, today's connectivity from drones to the ground station to cloud, drone to cloud, anywhere, 3G, 4G. But it's more about tomorrow's connectivity. How can we unleash and enable the higher levels of connectivity, much broader range, which provide the beyond visual line of sight kind of an operation. So in general, as Chris was mentioning on day one, drones plus anything is full of opportunities. We have numerous opportunities at our disposal. We are definitely at an interesting time in the history of drones. It means a lot of opportunities are going to be unleashed for this Internet of Everything. But let's try to think one fact. When the history of IoE will be written, it's just one question is going to decide whether the whole thing was a success or a failure. And that one question we all need to answer is, how did this IoE or drones or whatever we call it, whatever piece of technology we call it, how did IoE benefit humanity? Because in the end, nothing else matters. Thank you. In the end, nothing else matters. So the story has not yet been written. It's our job, everybody sitting in this room and everybody who was present last couple of days, it's our job. It is our story to write. What future will you write in this Internet of Everything? Let's think. And sky is literally the limit as far as drones are concerned. Thank you.